In this video, I want to have a look at problems that involve velocity when it's written as a function of x. So that means that velocity is given in terms of displacement rather than what we've already been looking at where velocity was given in terms of time. So in a lot of these problems, we can follow this sort of process here. So we're going to rewrite velocity v as dx dt. Then we can find the reciprocal of that to find dt dx, so finding t in terms of x. And then we're going to integrate that to find t as a function of x. Once we've got that, we need to use the other information that we're given to figure out what the constant of integration is. And once we have that, then we can rearrange that whole equation to make x the subject so that we have x as a function of t. So let's have a look at what that looks like in an example. So our first example tells us that the velocity of a particle is given by 2x squared over 3 centimeters per second. If x is equal to minus 3 centimeters when t is equal to 1 second, we want to find the displacement of the particle in terms of t. So what we're going to start with, we know that v is equal to 2x squared over 3. Rather than writing v, we can write that as dx dt is equal to 2x squared over 3. And then we could rewrite that. So we want to find dt dx. So we want to find the reciprocal of this. Rather than writing it, just flipping the whole thing upside down, I'm going to flip my 3 over 2, find the reciprocal of that. And then I'm going to write my x as an x to the power of minus 2. The reason I've done that is because it's going to make it a little bit easier having it in this form to integrate it in the next step. So to find t then, I'm going to integrate my 3 over 2 x to the power of minus 2 with respect to x. If I integrate that, my x would become an x to the power of minus 1, and I'd end up with minus 3 over 2 plus c. Now we need to figure out what c is. So we're also told that if x is equal to minus 3 over 2 when t is equal to 1. So that means from here, I can write that 1 is equal to minus 3 over 2, and then I've got minus 3 over 2 to the power of minus 1 plus c. Now this whole section here would work out to be 1 because when you flip this upside down, it all cancels itself out, plus c, which means that c is equal to 0. So that means my equation becomes t equals minus 3 over 2 x to the power of minus 1 plus 0. Now if I rewrite this, we want to make x the subject. So I'm going to rewrite this as minus 3 over 2x. Now I'm going to multiply everything by 2x, and I'm also going to divide by t. So I'll have 2x equals minus 3 over t, and then I can divide both sides by 2. So minus 3 over 2t. So now we have x, our displacement, in terms of time. For our second example, we're told that the velocity of a particle is given by the equation v equals 8 root x minus 1 meters per second. And we're told that after 3 seconds, the displacement is 17 meters. Then we're asked to find the particle's displacement after 2 seconds. So we're going to start. We know that v equals the square root, 8 times the square root of x minus 1. So if we rewrite that as dx dt, I'm going to rewrite this as well to x minus 1 to the power of half. Now we want to find dt dx instead, so we want to find the reciprocal. So the reciprocal of 8 is 1/8, and I'm just going to rewrite this as an x minus 1 to the power of negative a half. Now to find t, we want to integrate 1 on 8, x minus 1 to the power of minus a half dx. If we do that, we're reversing the chain rule, so we're going to have x minus 1, and that power we'd add 1 to 2, so it would become a half. We have this 1/8 out the front still, but we need to divide by the new power. So we could divide by a half, but that's the same thing as timesing by 2. And we also have a constant of integration. So what that becomes is the square root of x minus 1 all over 4 plus c. Now we need to figure out what that c is. So we know that after 3 seconds, the displacement is 17 meters. So we can write 3 is equal to the square root of 17 minus 1 all over 4 plus c, which would mean 3 equals 1 plus c, so c is equal to 2. Now if c is equal to 2, that gives us t is equal to the square root of x minus 1 over 4 plus 2. Our last step then is to rearrange this to make x the subject, and then we can substitute in. So if we rearrange this, I'm going to multiply everything by 4 to get rid of that fraction. We're going to have 4t is equal to the square root of x minus 1 plus 8. If I subtract 8 from both sides, 4t minus 8 is equal to the square root of x minus 1. Now I'd have to square both sides to get rid of that square root sign. So 4t minus 8 all squared equals x minus 1, which means that x is going to be equal to 4t minus 8 squared plus 1. If you go through and expand that out and simplify it, we're going to end up with 16t squared minus 64t plus 65. And the last step there is find the particle's displacement after 2 seconds. So at t equals 2, I'm going to substitute that in there. So I'd have x is equal to 16 times 2 squared minus 64 times 2 plus 65, which would give me 1. And that is 1 meter. So its displacement after 2 seconds is 1 meter. Our third and last example says if a particle has velocity given by v equals 6x cubed, and the particle is 1 centimeter to the left of the origin after 3 seconds, in part A we want to find its exact displacement after 2 seconds, and we want to make it have a rational denominator. So part A is going to be fairly similar to what we've been doing already. So v equals 6x cubed, which means that dx dt is equal to 6x cubed. So to find dt dx, we'll take the reciprocal. So we'd have 1 6 x to the minus 3. To find t then, we're going to integrate that. So if we integrate that, we're going to end up with minus 1 over 12 x to the power of minus 2. So we've increased the power, and then I've divided this fraction out the front, the 1/6, by that new power. So dividing that by minus 2 is where my minus 1/12 came from. I also have a plus c on the end. So to figure out what that plus c is, we need to use this extra information. So we're told that at t equals 3, our particle is 1 meter to the left. So that means x is equal to minus 1. So we're going to have 3 is equal to minus 1/12 times minus 1 to the power of minus 2. Or actually, before we do that, I'm going to rewrite it. So I'm going to have t equals minus 1 over 12x squared plus c, just to make it a little bit nicer. So then if I sub in, plus c, and we can rearrange that to figure out that c is going to be equal to 37 over 12. So that then gives me t is equal to minus 1 over 12x squared plus 37 over 12. Now we want to rearrange this to make x the subject. The first thing I'm going to do is multiply everything by 12 to make it look a little bit neater. So 12t equals minus 1 over x squared plus 37. Now if I minus 37 from both sides, so 12t minus 37 is equal to minus 1 on x squared. If I divide by minus 1, that'll give me 37 minus 12t equals 1 on x squared, and then I can just find the reciprocal of both sides. So my x squared would be equal to 1 over 37 minus 12t. And then I need to take the square root of both sides. Now when you take the square root, you should be taking the positive or negative square root. But our displacement can't have a positive or negative. It can't be in 2 places at once. So we need to use the information that we're given up top. So we are told that at t equals 3, x is equal to minus 1. So if we substituted 3 into here, we need this whole thing to come out to give us a negative. So that means that the denominator has to be the negative square root. The last part of that asks us to find its exact displacement at after 2 seconds. So at t equals 2, we're going to substitute that in. So we'd have x equals 1 over minus the square root of 37 minus 12 times 2, which is going to give us 1 over minus the square root of 13. And then if we rationalize the denominator of that, we're going to end up with minus root 13 over 13, and that's in centimeters. For part B of our question, we're asked how long is our particle in motion? So we've just figured out that displacement is given by this formula here. So one way of thinking about this question is, if we're trying to figure out how long it's in motion, we want to figure out what values of t this function can take on. If we're thinking about what values of t it can take on, that means we're thinking about the domain of this function. So looking at the domain of that, we know that this number down here is in the denominator, so it can't be equal to 0. And because this is under the square root sign, it can't be negative. So that means our 37 minus 12t has to be positive. It has to be greater than 0. So that means that minus 12t has to be greater than minus 37. And that means that t would have to be less than 37 over 12. So if we convert that to a decimal, our t is going to have to be less than 3.083 seconds. So it's in motion for 3.083 seconds, or just underneath that. All right, so that's having a look at velocity as a function of displacement.